Welcome to lecture 4 of module 4, and today we are going to see the topic address resolution protocol. In the last video session we have been discussing on the internet control protocol. In that we have discussed the internet control message protocol. Okay, so today we are going to see the address resolution protocol. So before going into the address resolution protocol, we need to understand the concept of address mapping. Okay, so when a packet or when a data is transferred from one node to another node, we are actually dealing with two different types of addresses. Okay, so one is called the logical address. Okay, logical address. So what is a logical address? Logical address is nothing but the IP address. Okay, that IP address is actually used for addressing the each and every network. Clear? Now next address is called the physical address. So physical address is nothing but our MAC address. Okay, so physical address or MAC address is nothing but is a address that is assigned to the interface of the components or the interface of the router or the host. Okay, so each host or each router will be having a network interface card, NIC card, or an interface. For that NIC we are having different addresses. That is called MAC address. That is the purpose of MAC address. Okay, so we must know both the IP as well as the MAC address for transferring a packet from one host to another host. Okay, so let us see this with an figure. Okay, so look here. So suppose we are having a sender here and this is our receiver. Okay, so we need to transfer a packet or we need to transfer a data from sender to receiver. Okay, so this is our data. So data is generated by the sender. So here we have it is written A/10. So here A is the IP address of the sender and 10 is nothing but the MAC address of the sender. Okay, so the sender has the IP address as well as the MAC address. Okay, so this data is being processed and this data is being given to the network layer. So when this data is being given to network layer, they will encapsulate the data with what? They will encapsulate the data with a header. That header contains two information. What information? The source IP and the destination IP. Okay, so here A is the source IP. Okay, A is the source IP and P is the destination IP. So here this is the destination system and the destination system's IP is P. Okay, so here it is P. Actually the IP address format is in the 4 octal format, but for easy representation I have given it as A and P. Okay, so here it is A and here it is P. Okay, and this packet is being transferred to data link layer. Okay, when it reaches the data link layer, the data link layer attaches the header and the trailer. They will again encapsulate it. Okay, by attaching a header and the trailer. Okay, so the header and the trailer. The header contains two informations. What? The MAC address, the source MAC address, and the destination MAC address. Okay, so here the source MAC address is 10. Okay, the destination MAC address is 20. But here, look at here. Here the destination MAC address is given here is what? 95. 95 one. But here it is written as 10. Here it is given as 20. Why? Because when it reaches the data link layer, it will give the MAC address of the adjacent router. Okay, it cannot reach the destination. This system cannot reach the destination directly. He will be going through this path. He will going to this router. Okay, then to this router, and finally he will be reaching here. But this packet or this host will be knowing only the host MAC address of this router or this interface. Okay, so this interface MAC address is 20. Okay, so that is why given it is 20. So this packet will be reaching to this router, to this interface. So this router will be having different interface, and each of these interface will be having different MAC address. So for this interface, the MAC address is F, MAC address is 20, and the IP address is F. Okay, for this interface, the IP address is T and the MAC address is 99. Okay, so this packet will be reaching here. So this router will take that datagram and he will decapsulate it. Okay, he will remove this header and trailer and take this packet. So when he reads the packet, he finds that here the source IP address is A and the destination IP address is P. Okay, so he understands that his IP address is what? His IP address is F. So he understood that this packet is not meant for me. So I will move to the next router. Okay, so what he does, he will take this packet and again encapsulate it with the neighboring router. Okay, encapsulate it with the MAC address of the neighboring router. Okay, so look at here. So this packet is again encapsulated with the 33 and 99. Okay, what is 99? 99 is this source MAC address. Okay, that is this packet is coming from this 99. Okay, 33 is the destination. Destination is the next router's MAC ID. Next router's MAC ID is 33. Okay, that is here. That is written here. Okay, അപ്പോൾ തൊട്ടടുത്തുള്ള റൗട്ടർ ഇൻ്റർഫേസിൻ്റെ MAC ID ആയിട്ട് അത് റീപ്ലേസ് ചെയ്യും. Okay, so again this datagram is being transferred here. Okay, so when it reaches this interface, this router interface, again this will be decapsulated and this packet is recovered. Again he reads it. Here he reads it. Here the IP address, source IP address is A and the destination IP address is P. Okay, so he understood that this is not meant for him. Why? Because the IP address here it is N. So he understood that this packet is not for him and he has to transfer it to the next router. Okay, so he will transfer it to the next router. Okay, so here he founds, here he what he does, he will take the data, he will take the packet, then he will encapsulate with his source MAC address. His source MAC address is 66 and the destination MAC address is 95. Okay, so straight away this is going to this host, so the destination MAC address is 95. Okay, now he will pass on to this datagram to this host. When this host taken this, he will decapsulate it and he finds that as the source IP address is A and the destination IP address is P. Okay, so he understood that this is for me because his IP address is actually P. Okay, so he understood that this is for me and he will take that data. Okay, this is the procedure how this data from source to the source reaches the destination. Okay, first here the IP address is given. Okay, when it reaches the network layer, he will append the MAC address of the neighboring routers or the host. This is the purpose. This is how it is going. Okay, so the summary is that in order to transfer a datagram from one node or router to another host or router, we require two types of addresses. What is that? The first one is the IP address and the second one is the MAC address. Okay, so IP address is called the logical address, IP address is called the logical address and the MAC address is called the physical address. Okay, this is the basic concept in IP addressing. Okay, this is the basic concept in address mapping. Okay, so what is the purpose, what is the address mapping? Okay, so delivery of a packet to a host or a router requires two levels of addressing, logical and physical. We have already explained that. Router and the host in the internet is identified by the IP address. The packet to reach there, it needs a physical address. Okay, so router and the host is identified by their IP address. To packet to reach the physical address, the packet to reach the interface, it requires the physical address. Okay, need to map to a logical address to its corresponding physical address and vice versa. So for that, what we do, we'll be having a host will be having the IP address, but he does not know the MAC address of the router. So he has to find out the MAC address, or he has to map a logical address to a physical address. He want to map a IP address to a MAC address. Okay, so that mapping is required. Clear? So need to map a logical address to its corresponding physical address. അതായത് ഒരു IP അഡ്രസ്സിനെ നമ്മൾ ഒരു MAC അഡ്രസ്സായിട്ട് മാപ്പ് ചെയ്യണം, അല്ലെങ്കിൽ തിരിച്ച് മാപ്പ് ചെയ്യേണ്ടതായിട്ട് വരും, or vice versa. Okay, these can be done by using two types of mapping technology, that is static and dynamic. Okay, so static means we will be having a table and using the table we will map the IP and MAC ID. Okay, in dynamic mapping we are actually dealing with the dynamic mapping. Okay, so dynamic mapping, each time a machine knows one of the two addresses, okay, logical or physical, it can use a protocol to find the other one. Okay, so here we have a machine that knows the two addresses. We are having a machine or a system that knows two of these addresses, logical and physical. Okay, it knows any one of the addresses and it uses a protocol. Okay, ആ മെഷീന് ഏതെങ്കിലും ഒരു അഡ്രസ്സ് അറിയാമായിരിക്കാം, ലോജിക്കലോ അല്ലെങ്കിൽ ഫിസിക്കലോ. ഓക്കെ, എന്നിട്ടൊരു പ്രോട്ടോകോൾ ഉപയോഗിക്കും. ആ പ്രോട്ടോകോൾ ഉപയോഗിച്ച് യൂസിങ് ദാറ്റ് പ്രോട്ടോകോൾ ദേ വിൽ മാപ്പ് ദ ലോജിക്കൽ അഡ്രസ് ടു ഫിസിക്കൽ അഡ്രസ്. Okay, that protocol is what we are going to study today. That is called address resolution protocol. Okay, so ARP, address resolution protocol, is a protocol that is used to map a IP address to MAC address or a logical address to physical address. Next one is reverse address resolution protocol that you will be seeing in the next video. That is a protocol that is used to map a MAC address to IP address or a physical address to logical address. Okay, അപ്പോൾ ഒരു IP അഡ്രസ്സിനെ MAC അഡ്രസ്സുമായിട്ട് മാപ്പ് ചെയ്യാൻ ARP യൂസ് ചെയ്യുന്നു. ഒരു MAC അഡ്രസ്സിനെ IP അഡ്രസ്സുമായിട്ട് മാപ്പ് ചെയ്യാൻ യൂസിങ് RARP. Okay, that is a summary. Clear? So we are actually going to study the address resolution protocol today. Okay, so what is address resolution protocol? Anytime a host or a router has an IP datagram to send to another host or router, it has a logical IP address of the receiver but not the physical address. Okay, അപ്പോൾ ഒരു സമയത്ത് ഒരു ഹോസ്റ്റിന് he's having a IP datagram. In order to transfer that IP datagram, he is having only the logical address or the IP address. So he want to know the physical address also for transferring the IP datagram. This means that the sender needs the physical address of the receiver. A receiver and physical address വേണം. The IP datagram must be encapsulated in a frame to be able to pass through the physical network. അപ്പോൾ നമ്മൾ IP ഡാറ്റാഗ്രാമിൽ നമ്മൾ എന്ത് ചെയ്തു? ഹാവ് ടു ബി എൻക്യാപ്സുലേറ്റഡ് ഇൻ ടു എ ഫ്രെയിം. ഓക്കെ, ആരാ ഫ്രെയിം ചെയ്യുന്നത്? ദ IP datagram is actually encapsulated into frame by whom? By which layer? It is done by the data link layer. അത് നമ്മൾ കണ്ടു കഴിഞ്ഞു അല്ലേ? The figure we have already seen. This is made into frame by which layer? Data link layer. This is called a frame. Okay. In that frame we are having the source MAC ID and the destination MAC ID. Okay. So the IP datagram must be encapsulated in the frame, must be able to pass through the physical network. All the physical networks through this IP datagram is encapsulated into a frame, and this frame is being transferred to different physical networks. Okay. So this address resolution, in order to understand, if a host want to know the MAC ID or the physical ID of the his destination, what he does is, here look at this figure. Okay, here the system A, okay, system A is looking for the physical address of this physical address of the system. Okay, so what he does is, he want to know the MAC address of each and every individual routers or the host that is in between the system A and system B. Okay, so what he does is, he will request a message. That message is called the ARP request. So this ARP request message is being broadcasted to each and every node or each and every host or each and every routers present in between A and B, source and the destination. So when each of these routes or each of these routers or each of these hosts each of these routers or the host gets this request, they will reply. Okay, they will reply using a ARP reply message. Okay, so who is going to reply? He wants the address of whom? He wants the address of this destination. Okay, but in between there are here the system A is connected with many routers, but he want to reach here, he want to reach to this system. Okay, so only this system will respond. Okay, so he will send the ARP request as a broadcast message. Okay, and everyone will be getting this broadcast message. Only the actual recipient will take that broadcast message and give the reply. Okay, only this station B or the system B only will give the reply. Because why? Because the system B is the intended recipient. Only that system will give the reply. Okay, such reply is called ARP reply, and this ARP reply is actually unicast. So why it is unicast? What is the meaning of unicast? Unicast means one to one. Broadcast means what? Broadcast means one to many. Okay, so here the unicast means one to one. So here the reply is actually in a unicast form, but the request is actually in the form of broadcast. Clear? This is called ARP. This is called address resolution protocol. Okay, so a source, he has the IP address and he wants to know the IP. He knows the IP address of the destination, but he wants to know the IP address of whom, he wants to know the MAC address of whom, the destination. Okay, so this system knows the IP address of system B. This is the IP address, but he want to know the MAC address also. For that he will give a request to everyone. Only this one will be responding. Clear? This is what? This is the MAC ID. Okay, this is the MAC ID of the system. This will be reply. Now let us see the explanation. The same thing. The host or the router sends an ARP query packet. The packet includes the physical and the IP address of the sender. So what this packet contains? This packet contains the address of system A, the IP address of system A, the MAC address of the system A, and also the IP address of the system B. These three informations will be contained in this request. Okay. So the packet includes the physical and the IP address of the sender and the IP address of the receiver. The query is a broadcast over network. The query is actually broadcasted. It is given to each and every nodes present in connection with the system A. Okay, connected with the system A. Every host or the router on the network receives the receives and processes the ARP query packet, but only the intended recipient recognizes its IP address and sends back the ARP response packet. Okay, so each and everyone will be receiving this. Only the intended receiver will be taking that, processing it and giving the response. So how he understood that he is the intended? Because in the IP request packet they have given the IP of the destination. By reading this, he knows that he is the intended recipient. Okay. The response packet contains the recipient IP and the physical address. Okay. So the response packet, what does the reply or the response packet contain? The response packet contains two information: the IP as well as the MAC ID of the system or the recipient. That is sent to the system A in a unicast message. Okay. The packet is a unicast directly to the inquirer. Inquirer means the sender, by using the physical address received in the query. Okay, so they are actually transferred. The reply is actually transferred in a unicast message by using the IP address of this system. Okay, so this is the clear. This is the method. This is the ARP request and response. Now this is the ARP request response message format. Okay, this is the ARP request response message format. So this is a 32-bit message, and it contains different parts. The first one is the hardware type. This is a protocol type. So hardware type is actually the 16 field. It is actually a 16 16-bit field. It is a 16-bit field defining the type of the network on which ARP is running. Okay, ARP run ചെയ്യുന്ന നെറ്റ്വർക്ക് ഏതാണ്, whether it is a LAN, WAN or something else, okay, or Ethernet or anything. Okay, so the type of network is the hardware type. Okay, so hardware type represents the type of the network. Now protocol type. The protocol type defines the defined protocol. This is a 16-bit field defining the protocol. ഇത് ഏത് പ്രോട്ടോക്കോൾ ആണ് ഉപയോഗിക്കുന്നത്? IP ആണെങ്കിൽ we are having the protocol IPv4. Okay, IPക്ക് രണ്ട് പ്രോട്ടോക്കോൾ ഉണ്ട്, IPv6 ഉണ്ട്. Okay, if we are using IPv6, we will write IPv6. They are having a protocol type. Okay, so IP യുടെ പ്രോട്ടോക്കോൾ ഏതാണ്? That is represented here. Okay, the type of network that we are using, that is represented here. Okay, both are 16 bits. Okay, next is hardware length. Okay, so hardware length is actually the physical address of this hardware. Okay, this is the 8-bit field defining the length of the physical address. Okay, this is the MAC address. Okay, this is the MAC address of that particular hardware. or the router or that particular hardware. Okay, so protocol length. The protocol length is the 8-bit field defining the length of the logical address. Okay, so this defines the length of the IP address. That means that this hardware length is showing the length of the length of the MAC address that we are going to use, and this specifies the length of the IP address. Okay, so all of you are knowing the length of the IP address, which is 32 byte or 6 byte, 32 bits or 6 byte, sorry 4 bytes, right? So MAC address is actually 6 byte in length. Okay, that is 48 bits. Clear? അപ്പോൾ ആ ഒരു ലെങ്ത്ത് എത്ര ലെങ്ത് ആണെന്നുള്ളതാണ് ഇതിനകത്ത് വരുന്നത്. Clear? So here it will be written as 6 bytes and here it will be written as 4 bytes. Clear? Next is operation. So this is a 16-bit field defining the type of the packet. Okay, അത് ഏത് ടൈപ്പ് ഓഫ് ഓപ്പറേഷൻ, റിക്വസ്റ്റ് ആണോ റിപ്ലൈ ആണോ, ARP റിക്വസ്റ്റ് ആണോ റിപ്ലൈ ആണോ. ഓക്കെ, അതാണ് ഓപ്പറേഷൻ എന്ന് പറയുന്നത്. ക്ലിയർ? The operation represents the type of the ARP message, whether it's a request message or a response message. Okay, so that is a hardware type, prototype type, hardware length, protocol length and operation. Clear? Next field is the sender hardware address. Sender hardware address is the MAC address of the sender. Next is the sender protocol address. Sender protocol address is the IP address of the sender. Okay, so here target hardware address. Target hardware address is the MAC address of the receiver. Okay, so initially this will be 0. Will be unknown about this MAC address of the destination. So this will be blank. The last one is the target protocol address. That is the IP address of the destination. Okay, അതാണ് ഈ 4 field. So first field is the sender hardware address, that is the MAC address of the sender. This is the sender protocol address. This is the IP address of the sender. This is the target hardware address, that is the MAC address of the receiver. This is the target protocol address, that is the IP address of the receiver. Okay, so this is the frame format of the ARP packet. Clear? So the explanation for this is given here. Clear? Now next one is ARP packet encapsulation. So this ARP packet is actually encapsulated into our data link frame. Already we have learned about this data link frame. Okay, so this ARP packet is along, so this is the data link frame. So this ARP request reply packet is actually integrated along with this data link frame. Okay, this is the format. Okay, so all these we have explained in the previous modules: preamble, destination address, source address, type, data, CRC. Along with this we are having this ARP request reply packet. Clear? We are going to discuss the 4 different cases in which the service of the ARP can be used. Okay, the ARP can be used for 4 different services. The first case is this one. Okay, so here there are 2 hosts and these 2 hosts are in the same network. So the data transmission is taking between these 2 hosts between the same network. Okay, so here the target IP address is actually the destination of this destination address in the IP datagram. So the IP packet or the IP datagram will be having a destination IP address. Okay, that will be the address of this host. Okay, now here next is what? Next is the a sender, a host is actually transmitting a datagram to a router. Okay, so this router is actually in another network. Okay, the host want to send a packet to another host on another network. Okay, so it must first be delivered to a router. Okay, so a host want to send a packet to another host. So this host is actually the destination host is in another network. In order to reach that network, he has to transmit the packet to this router. This router will transmit that packet to that destination. മനസ്സിലായില്ലേ? ഇപ്പോൾ നമ്മുടെ ഡെസ്റ്റിനേഷൻ ഹോസ്റ്റ് എവിടെയുള്ളത്? ഇത് വേറൊരു നെറ്റ്വർക്കിനകത്താണ്. അപ്പോൾ ആ നെറ്റ്വർക്കിലേക്ക് എത്തണമെങ്കിൽ ഈ ഹോസ്റ്റ് ആർക്ക് സെൻഡ് ചെയ്യണം? he has to send to this router. This router will forward that packet to the another host, to that host. Okay, so here the target IP address is what? here the target IP address is what? The IP address of this router. തൊട്ടടുത്തുള്ള നോഡിൻ്റെ IP address അല്ലേ ഇദ്ദേഹത്തിന് അറിയാൻ പറ്റുള്ളൂ. So the target IP address is the IP address of this router. Okay. Now the case 3, a router receives a packet to be sent to a host on another network. It must first deliver to the appropriate router. Okay. അപ്പോൾ ഇത് വേറൊരു ഹോസ്റ്റിൽ നിന്ന് വന്ന ഒരു പാക്കറ്റ്, ഇറ്റ് വിൽ റീച്ച് എ റൗട്ടർ. Okay. It has to be given to another network. For reaching that network, you have to transfer to the next adjacent router. ഇങ്ങോട്ട് ട്രാൻസ്ഫർ ചെയ്യണം. Okay. So here the target IP address is what? Here the target IP address is the IP address of this router. Okay. So where he is getting that IP address, he is referring to the table, routing table, and getting this IP address. Okay. അപ്പോൾ നമ്മൾ ഹോസ്റ്റ് നിന്ന് ഇപ്പോൾ ഇവിടെ we are having a host here. The host is transferring that to this router. Okay. From that router it is reaching this router. From this router we are getting the packet to this host, the final host. Okay. So the packet reaching here, the target IP address is the IP address of this router. Okay. Now the last one. The last one is a host. Host is a router. Okay. From this router it is moving to the destination host or the receiver. Okay. So the target IP address is what? The target IP address is the IP address given in the IP packet. In the IP packet we are having two addresses, source address and destination address. So referring to the packet, this router can understand the destination IP address. Okay. So the target IP address is the destination address of the IP datagram. Okay. Clear? So these are the 4 different cases. Okay, fine. So this is the concept of address resolution protocol. Clear? In the next session we will discuss the reverse addressing resolution protocol, that is RARP. Okay, thank you.